Now we're ready to face proteins. We've been in the world of carbohydrates with our biochemistry unit. We discussed the world of fats and oils. Now we're going to spend some time on proteins. As we examine proteins, we're going to look at kind of some information about proteins here. In class, we will actually use paper and scissors and tape, and we're going to create proteins and see their structure there. All right, so proteins. We know this is an important component of our diet. Even if you are a vegetarian or a vegan diet, you have to have proteins in your diet. It is a part of our body construction. We are built from proteins. So your hair, your nails, flesh, that's your muscles, okay? Hemoglobin in your blood. Enzymes are all proteins. What are enzymes? Enzymes are things that enable all the reactions that have to take place in our bodies to occur. So no reaction happens without an enzyme getting involved to help break down molecules that we eat and then reconstruct those molecules together to build what we are. Okay, so enzymes are a protein. Enzymes, which are a protein, are used to make the protein of your hair and your nails. So any one of our cells is going to have several thousand different proteins. It is an extremely important part of our makeup. You are going to be reading about the protein function in our body, so I'm going to assign that reading and might already have done so. You're going to be reading about how the proteins function in our body, what their jobs are there. What we're going to do is look at down on the level of the protein, the chemical makeup of those proteins. Proteins are a polymer, repeating unit, a polymer of amino acids. What you see here on the screen is an amino acid, and we're going to look at each of those parts a little bit as we go. But there are, just a limited number of these things. They can change based upon the green that you see there, that R group. They can change according to that R group. But everything else that you see there, the pink, the blue, the black, is identical from one amino acid to the other. So let's look at the different parts. The word amino acid has amino part, okay? The amino part comes from the word amine, okay? And we learned about the amine functional group in our organic unit. So there is an amine. A nitrogen with 3 bonds connected to it is an amine. Well, it's not just an amine, it's got the word acid in there. And the word acid, we know, comes from the term carboxylic acid. So we see a carboxylic acid group there. And we learned about that functional group when we talked about our organic functional group. So this is a very important part of that. There's only 20 different amino acids that we use to make proteins, okay? And that's the green part. As we change that green part, it could be a very simple green part, it could be a hydrogen. So it's not necessarily always a carbon group, it could just be a hydrogen. Or it could be a very simple R group and be a methyl group. And it can get more and more complex, but there's only 20 different ones that make up an amino acid. If you look at your book on page 340, you're going to see all the different amino acids. And I want you to take a look at those, just to familiarize yourself and to see the complexity or simplicity of those different R groups. You do not need to memorize them at all. This is not an upper level biochemistry class where we're going to force you to put the names with the amino acid. And there is no good systematic naming system for these at all. They all are very historically named amino acids. Biochemists are terrible about coming up with systematic names for their molecules, and so they've got a list of names associated with them, but you don't need to know those. Now, the proteins that are made up of these things linked together are all going to have functions based upon what their R groups are. Some R groups are water lovers. We call that hydrophilic. They love water. And some of them are water haters, hydrophobic. They're afraid of water. That's what that term means, depending upon the need of the function group. And we'll talk about that as we proceed. But depending on what the job of that protein is, will depend upon which amino acids are used to link together. So when we say they're a polymer of these amino acids, it's not the same amino acid repeated over and over and over again necessarily, but it is an amino acid group repeated over and over again with who knows what R groups attached. Okay, so depending upon the protein, it's going to have different R groups. Here are two different ones, and we're going to look at linking them together. We're going to learn what kind of reaction links them together, and we're going to practice this in class. The amino acid on the left is glycine. Now let's just examine it here a little bit and look at those pieces and those parts. We have the amine end, okay, that gives it the amino part of its name. We have the acid, that's the carboxylic acid end. We will have the C with the H attached, that never changes. So everything there never changes. But in glycine, the R group is just a hydrogen, and that's the name of that amino acid. Alanine, we have replaced the R group, or the R group is a methyl group. So that makes alanine. Now, the reaction that links these together is a condensation reaction. We saw this reaction. We practiced this reaction when we were talking about carbohydrates. We saw this reaction and we practiced this reaction when we made esters. In this reaction, we are going to remove a water molecule, as is the case with any condensation reaction. We are going to link these two guys together. So this will end up linking right up to here. And that will make whenever you link together by removing water, that's called condensation. So what does that give us? All right, this is going to give us, and let's see if I've got a picture of this. Boop, 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 ba-doop, ba-doop. Nope, I don't. I'm going to draw it, and then I'm going to erase it so that the words can come up next. So when you pull that out, you should be able to draw what you make. So you start over here and you go into over here and you're going to remove the water. So I'm going to start over here. I have my hydrogen, I have my nitrogen, I have my hydrogen, there's the amino group. I have my H down here, which makes it glycine. I have my C, I have my double bond O, and I have my bond, but it's not to the oxygen, it's to this nitrogen. So there's the nitrogen. Okay, that's that nitrogen, and then we just keep constructing. That had a hydrogen on it, that has a C, it has an H, it has a methyl group because it's alanine, it has a C, a double bond O, and an OH. Okay, that is what gets made. This bond that gets formed right here is called a peptide bond. All right, so that's a peptide bond. When you link amino acids together, you make a peptide bond. Now what I'm going to do is erase what we see here so we can see the words that come up. If you need to keep writing, stop it and do so, but I'm erasing. All right, slow erase here. Okay. So it says there it's a peptide bond. And the last thing that I wanted to show you here is this term dipeptide. We know what di means. Di means two. I have linked together two amino acids. There's only one peptide bond, but we call it a dipeptide. Dipeptides are the linking of two amino acids together. There is one peptide bond, but we call it a dipeptide. So let's look at a dipeptide that is very common in our society, and that is the sweetener aspartame. Aspartame is not a carbohydrate. Aspartame is a dipeptide. It is two amino acids that have been linked together. Now, it is a little bit more than that, because if it were truly just two amino acids, we would not have a methyl group here. We would have a hydrogen here. It would be an amine on this end, and it would be an acid on this end. But when you're talking about this, it's a dipeptide, except for we have replaced an H there with the methyl group. So this has got a strong sweet flavor for us. Okay, this is the amino acid called aspartic acid. This is a amino acid called phenylalanine, and we have replaced the H with a methyl group. Now, a lot of products that have aspartame will have a warning on the label. They will say that this has got, I don't remember exactly how they word it, but you'll see something about PKU. There are some people who have a condition where they cannot handle this amino acid, and they have to avoid aspartame. I have to avoid aspartame. I have never needed to avoid all proteins that contain that amino acid, but this guy gives me a headache like crazy, and so I no longer can drink any Diet Coke that has aspartame in it, and I have to look for things that contain Splenda instead if I want a diet soft drink. In class, we will try a couple. You've got that in your notes. So we'll practice doing that together. You don't need to worry about it yet. The term polypeptide is when you have more than two. So a single amino acid is an amino acid. Two amino acids hooked together with this condensation reaction is a dipeptide. Once you have more than two, then you've got yourself a polypeptide. Polypeptide structure, when you've linked more and more of these amino acids together, is the beginning, not the end, the beginning of your protein structure. Endorphins is not a protein yet. It is a polypeptide, but endorphins are polypeptides. Endorphins occur naturally in the human brain. We produce those endorphins, and they are from a class of compounds called opioids. Now, opioids are what opium comes from. And so these endorphins will give us a high if we have a high content of these endorphins, but it's what we call a natural high. They are used to help reduce pain. If you are in a situation that is a painful situation, your body will quickly produce endorphins and help ease the pain. I shattered my elbow one time in gymnastics. I was a gymnast and I hit the ground really hard. Looked down at my arm and it was bent backwards the wrong way. We call it in shock, but I did not feel much pain at that moment in time because the endorphins kick in pretty quickly to try to, block out that pain. If somebody is into runner and they talk about the runner's high, they get to a point where they're no longer feeling the pain and they're just scooting through the world, running like the wind. That's the runner's high, and your body naturally will produce those endorphins to help block out the pain that I always feel if I ever try to run. So, what amino acids are hooked together to make this polypeptide called endorphin? It just depends. It is all driven by which amino acids, and we're not going to get into the amino acids that make up the endorphins. All right, we're going to stop with this unit there. We've talked about amino acids, dipeptides, polypeptides, finished with a little discussion about our endorphins. We want to enter the world of polypeptides with your next lecture.